Take two. So, hi chemistry class. Just a few short little things about our test in case I don't get to see you before tomorrow, before the next section. These are things that maybe you got wrong or you weren't sure about or whatever. And so these are things that I thought I should describe based upon looking at them. Start over here, we'll go this way. If you're going to draw particles, maybe for gases, you might want to show them separated like that in the container. If it's more than one thing, you might make the particles drawn bigger or smaller. If you make a really small volume like that, you might get to the situation where now they are so crammed together that, especially these big ones, they are close enough because they're so big that they're attracted to each other. Because they're attracted to each other, they're not attracted, they're not bouncing off the container, so that's less pressure. Those little tiny guys there, because they're so much smaller, maybe they don't feel that as much, so they might be actually a higher pressure. But this is definitely kind of like a non-ideal gas situation. Not ideal when we've got low temperatures and high pressures. Down here, if you're going to draw something like, say, sodium chloride, if it happens to be a solid, you wouldn't do that. You'd make them like bumped right up against each other. You'd also want to make, if it's sodium chloride, the correct number of them, like 1 to 1. Make them the correct size and label them. Don't just draw like plain circles because the grader doesn't know what those circles represent. If we do problems with this light stuff, like wavelengths of light, you can find the energy of a photon. You might need to use the speed of light. It's on your equation sheet. And you might even find a wavelength of light, but if it says nanometers, make sure you convert. A lot of people didn't do that. If you've got a problem or something that involves a compound, something like this, what we've got, magnesium bromide, there's 2 bromines there. So if you were to dissolve this into water, I would instead make 1 magnesium, this is not to scale, and we'd have 2 bromines. So this 2 of them might actually make your concentration twice as much, because there's 2 of them. If we've got a gas law thing, we might be talking about pressures and volumes and stuff. If we've got the volume sealed up, we did this in class with a can of soda, where we heated up the water inside. The volume didn't change at first. The pressure outside and the pressure inside was the same. But then we put it in ice water. The ice water made it get colder. So colder on the inside, less kinetic energy, less pressure on the inside. If there's less pressure on the inside, there's more pressure on the outside. We crushed it. So, quick review of stuff that people got wrong. I didn't want people to be too unprepared for the second part of the test. I hope this helped.